Once upon a time, I was a beekeeper in Oregon on the North Coast. I rented hives for pollinating cranberries and sold honey at a local health food co-op. Upon becoming fairly stable in Alaska, I began to look into the feasibility of keeping bees here, attending local beekeeping association meetings and asking questions of local beekeepers. One question kept giving mixed results. Are you successfully bringing your hives through the winter? This class gave me the opportunity to create a survey based on overwintering success of Alaska honeybees. I joined several Facebook groups in different regions of the state, posting the survey and collecting the data. Data were edited to fit the presentation format. These data are random samples collected from voluntary responses. For this presentation, the question, did you attempt to overwinter your bees, was the most important question. Out of 50 responses, 38 replied yes, 12 replied no. These data were used to compose this binomial distribution chart and form the basis for the null hypothesis proportion test. This is the equation used to get the z-test score. It's the sample proportion minus the null divided by the square root of p hat times q hat divided by the sample population, which gives the z-test score. From the tables, this is converted to a critical value, which gives parameters for rejecting or failing to reject the null hypothesis. In this case, the critical value is less than the z-score, so with 95% confidence, we conclude that there is a higher than 50% chance that someone attempted to overwinter colonies. This chart represents the frequency distribution of the bee breeds. For the purposes of this presentation, hybrid and Caucasians were combined as other. Without proving anything, it seems that a couple of breeds seem to have a higher likelihood of survival. And this is a graph of the ANOVA test results. This test is used to test the variance between the breed populations. The percent survival by breed was entered into the Excel as a table, and the ANOVA single factor test was run, comparing all of the means, which resulted in a p-value used to determine whether to reject or fail to reject the null hypothesis. In this particular case, because the p-value of 0.767 was greater than the significance value of 0.05, we reject the null hypothesis. There is insufficient evidence to reject the claim that the 6 samples come from populations with means that are all equal. On the basis of this ANOVA test, we cannot conclude with 95% confidence that any mean is different from the others. But we can informally note that at least one group is much lower than the others. Perhaps some bees should stay in Italy. This is simply an attempt at a good beginning. There is no conclusion. It's important to continue to share these data in order to improve the odds of successful winter survival of honeybee colonies. With today's technology, efforts can be coordinated and continually updated. More data over more time will continue to yield more results. I'd like to thank all the participants, and particularly my instructor, Jenny Weber. Without your support, none of this would have been possible.